Okay, let's talk about something that affects almost every machine on Earth: friction and wear, and a tiny little particle that might just change everything. We're talking about a carbon sphere, way smaller than a virus, that acts like a microscopic ball bearing. This is the story of the carbon nano-onion and how it could literally save our engines.
So why is this such a big deal? Well, it all starts with this number, 80%. Think about that for a second. According to a 2019 review, a staggering 80% of all machine failures come down to one single cause: wear and tear. That's 4 out of every 5 times something breaks down.
And the scale of this problem? It's just immense. Friction isn't just a little annoyance, it's a colossal energy vampire. The same study found that the energy loss just fighting friction chews up about a third of all the industrial energy we use on the entire planet. That is an incredible amount of wasted power and money.
Now, for centuries, we've had a go-to champion in this fight, the reigning king of solid lubricants, graphite. Yeah, you know it as the lead in your pencil, but in the world of engineering, it's an absolute workhorse.
So how does it work? Well, it's all about its structure. Imagine flat sheets of carbon atoms, all stacked up like a brand new deck of cards. These layers slide over each other with almost zero effort, and that's what gives graphite that super slippery feel. It's been the best tool we've had for a very, very long time. But here's the catch. Those flat sheets have edges. And according to a key 2008 study, which we're going to dig into, those sharp edges can act like microscopic razor blades, scratching and scraping away at the very surfaces they're supposed to be protecting. So while graphite is great at cutting down friction, it can actually cause wear at the same time.
So, if graphite is the old guard, what's the new contender stepping into the ring? Well, let's meet a truly fascinating material called the carbon nano-onion.
And here they are. This isn't dissimulation, this is an actual high-res microscope image from that 2008 paper. Just look at that perfect, nested structure. You can literally see the layers of carbon, one inside the other, forming this almost perfect sphere. It's just incredible engineering by nature.
So what exactly are we looking at? A carbon nano-onion, or CNO for short, is a tiny particle made of multiple nested shells of carbon. The absolute best analogy? Think of a Russian nesting doll, but made entirely of carbon and less than 10 nanometers across. We're talking unbelievably tiny and just beautifully elegant.
And this right here, this slide gets to the heart of the whole thing. Graphite is flat, two-dimensional, with sharp edges that slide. But carbon nano-onions are spherical, three-dimensional, with no edges at all. And that means they don't just slide, they can roll. That one single difference, it changes absolutely everything. All right, time for the showdown. How do these two materials actually perform when you put them head-to-head in a real-world lab test? Let's find out.
This is the exact question the researchers in that 2008 paper wanted to answer. So they took a standard base oil, added a little bit of either graphite or carbon nano-onions, and put them through the ringer to see what would happen.
And here's the first result, which is really fascinating. These graphs show the friction over time. The top one is for the nano-onions, the bottom one is for graphite. And at first glance, they look pretty much identical, right? Both materials are fantastic at reducing friction, bringing it down to a really low, stable level super quickly. On this metric alone, you'd call it a tie.
So yeah, if you only cared about friction, you might just call it a draw and go home. But remember, friction is only half the battle. The real story, the one that really determines how long a machine will last, is all about wear.
And this is where the nano-onions just pull away from the pack. The data from the study is crystal clear. When the researchers measured the wear scars left on the steel surfaces, they found that the parts lubricated with carbon nano-onions showed 20 to 30% less wear than the ones using graphite. That's not a small difference. That is a massive improvement.
And you don't need a PhD to see the proof. The visual evidence is just undeniable. Look at that top image. That's the wear track from the graphite test. You see how it's wide and heavily scarred? Now look at the bottom image, the one from the nano-onion test. The track is so much narrower, so much cleaner. I mean, the difference is night and day.
So, why? What is the secret sauce here? What makes these little nano-onions so much better at protecting surfaces? Well, the answer is all in their shape.
It really comes down to a super simple idea. Rolling is better than scraping. The graphite sheets slide, but their sharp edges can catch and dig into the surface. The nano-onions, on the other hand, are perfectly round with no edges to get caught. They can just roll between the two moving surfaces. They basically become the world's smallest ball bearings, turning that damaging sliding friction into a much gentler rolling motion. You know, this diagram really helps visualize the physics behind it. It shows that even flat sheets of carbon, when you put them under enough pressure and stress, they naturally want to curl up into rolls. It's just a more stable, lower energy way to be. So the carbon nano-onions are kind of preformed into the most perfect, efficient shape for the job.
So what does all this mean for the future? Well, it suggests we are right on the edge of a totally new era in how we protect our machines from breaking down.
So let's just do a super quick recap. Friction and wear? Massive, expensive problems. Carbon nano-onions, these tiny, perfect spheres, are a potential game changer. They're just as good as graphite at fighting friction, but they're way better, 20 to 30% better at stopping wear. And the secret is simple. They roll instead of scrape.
And this isn't just a one-off weird discovery. As this quote shows, carbon nano-onions are part of a whole family of amazing new materials called graphene derivatives, and scientists are incredibly excited about them for their amazing lubrication properties. We're really just scratching the surface of what's possible when we engineer materials at the nanoscale.
And all of this leads to one final, pretty mind-bending question. As we get better and better at designing these tiny materials, atom by atom, could we one day create a lubricant that's so good it basically makes wear and tear a thing of the past? Could our machines someday last almost forever? Now that is a fascinating thought to end on.